Okay, so good afternoon, students, and sorry for this starting that means this session to a little bit late. Okay, so in the last lecture we have discussed about the some of the numericals, and we have discussed about the working of the filter turbine. Okay, so I hope you understand that one. Just give me some time. I will post all the notes of the first unit along with the MCQ questions at just that means up to the end of this week. Okay, so just bear with me. So I hope the unit number one is clear to you. Meanwhile, you just read the books. If you have purchased the books for these systems in mechanical engineering, so refer that one. And I will put all the video recorded video lectures on our Google Classroom along with the first unit notes prepared by me and MCQ questions. Okay, so you just go through all the MCQ questions and solve it. Okay. So now we'll start with the second unit. Okay. So second unit is again it is a simple one as similar to the first unit, and it is deal with what the thermal engineering. Okay. Now we will see what is there in this unit now. Okay. So now let us check. Let us check this now. Just give it. Okay. Now just see this one. Okay. Let me take the. Okay. Now, okay, we'll start with the thermodynamics now. Now, the first thing, now we are dealing with the first that means the unit that is the thermal engineering. So, thermal engineering, it is deal with what? The thermodynamics. Okay. So, thermal engineering is what? Thermodynamics. So, this is the subjects for the mechanical engineers in the second year. So, thermodynamics. Now, this thermodynamics is what? Thermo means what? It is thermal or thermo. Thermo means it is heat. Okay, and the dynamics means what? It is the force. Okay. So that is means the the transfer of the heat. Okay, so the total meaning of the thermodynamics what it is the heat, and dynamics means the force. So it is defined something like this: the fundamental science that describes the basic laws. Okay, so it is first of all the science, and it denotes the basic laws. So you know the thermodynamics laws, so that everything comes in this unit. Okay. So will that one, and it deals with what? It deals with the different physical processes which involves the transfer or transportation of energy. So it deals with mainly the transfer of energy in the form of the heat, okay, or any other types of energy, and the relationship among the different physical properties of the substance which are affected by such processes. Okay, so it deals with the transfer of energy and the how that transfer of energy affect the properties of that particular substance. So it deals with the subject. Okay. Now, the laws of the nature formed by the observation and common experience by lay the basic frame of the thermodynamics. So here it is the all the laws. So if you see the thermodynamics laws, so they are taken from the that means the laws of the nature. Okay. So what is we will see in the nature. So that is just written in the form of the words. Okay, in the form of the text, and that comes in the forms of what? Thermodynamic laws. Okay. So just remember this one. The definition is it is just for your the reference only. So definition of the thermodynamics. Okay. Now we'll see just the basics of this thing. You know this one. You already studied this one. What is the thermodynamic system? Now the thermodynamic we have here is the system. We have surrounding and we have the boundary. Okay. So system, surrounding, and this system in between the system and surrounding we have the system boundary. Now, what is this system? So, the system is defined as what? Definite quantity of matter or region in space upon which the attention is focused in the analysis of the problem. Okay. So, if you take any system, that any system is what? If you take here some, suppose here I'm taking here suppose a refrigerator. Okay. So, if I take the refrigerator, so then this becomes my system. Okay. So what is there inside the system, so that is a matter. Okay, matter. Okay, so that is the mass, everything what is there inside the this refrigerator, so we call that as a mass. Suppose if I am considering the atmosphere, suppose this is our atmosphere, and instead of in this atmosphere I am considering this small part of the atmosphere. So this is what? This is region in space. Okay, and I am concentrating on this part only, so this is my region in space. So I will call this as a system. Okay, this is my system. Oh, this is what? This is a region in space, and this is what? This is the matter, quantity of matter. I am considering here some quantity of matter. So that is considered as what? That is considered as the system. Okay, so this is the system. Now everything which is outside the system, we call that as the surrounding. Okay, so everything which is around me or around you, so you call that as a the surrounding. Okay. So suppose we will consider you are sitting in a room now. Okay, you are sitting in the room. Okay, now you have mobile with you, and we are now you are listening the lecture. So if you consider the air inside in your room, so that becomes your what? That becomes your system. Okay, that means if you want to calculate the properties of your the air inside your room, you want to know what is the temperature of the air. Okay, what is the density of the air in your room. So we have considered what all the air inside our room. So this room. Okay, so we'll consider that as a system. Okay, now everything which is outside your room. Okay, if you see the outside, so the everything is there. So we call that as a surrounding. And your room and the surrounding, they are separated by the walls of this room. Okay, so we call that as a system boundary. Okay, so that we call that as a system boundary. Okay, so this is the simple definitions of what system surrounding and the system boundary. Okay, so in thermodynamics, suppose if we take something to analyze or to study, so we call that as a system. Simple words. Okay, you take something to study, to that is your system. Everything which is outside that system, we call that as a surrounding. Okay, and the boundary which separate the system and the surrounding, we call that as a boundary, or the walls. Okay, or the walls which separates the system and surrounding, we call that as a system boundary. So three things you have to just remember, these three definitions. So thermodynamic system. Okay, everything which is outside, that is surrounding, and in between these two, the separation of system and surrounding, that is formed by means of the boundary. Okay, so this is the definition of the three things. Now we'll see the different types of the systems now. Okay, now what is this? We have seen the systems. Okay, here we have seen the system. So everything which is under consideration for our study. ओके, जे पण आपण आपल्याला स्टडीज करण्यासाठी आपल्याला लागत आहे. सो आपण तो जो जी क्वांटिटी घेतली आहे किंवा स्पेस घेतला आहे, वी कॉल दॅट एज अ सिस्टम. नाउ सिस्टम इज क्लासिफाइड इनटू थ्री टाइप्स. वन इज कॉल्ड एज व्हाट? ओपन सिस्टम. Now what is this open system? So open system means what? It allows the transfer of mass. Okay, mass can enter. Okay, there is a transfer of mass. That means mass can enter and mass can comes out. Okay, in and out. At the same time, there is the transfer of the energy also. That means a system in which mass is permitted. That means mass can enter, or from the inlet, from outlet it can come out. And at the same time, there is a transfer of energy also. So energy comes, energy out. Okay. So in the form of the heat and the work. So if this is happening in the form of heat and work, so we call, and with what? With the environment. So outside we have what? Surrounding, environment or surrounding. Then we call that as the open system. Okay, we call that as a system. Okay, so consider, suppose this is the imaginary system. You have considered this system. Now here two words you have to remember. The mass can enter. Okay, there is an exchange of the mass and there is an exchange of the energy also. Okay, with the surrounding. So then it is called as what? Open system. Now what are the examples of this open system? Now you consider here turbine. Now if you consider, we have considered the turbine, the steam enters into the turbine, and then afterward, then the steam, it goes to the condenser. Okay, after doing the works in the turbine, okay, steam enters into the turbine and then it comes out through the outlet and then it enters into the condenser. Okay, that means here it is here what we have here the mass of steam. Okay, so M1 is the mass of steam and then M2 is the mass of steam. So there is what? There is an exchange of mass. And then what is the exchange of energy? The steam is having very high temperature. Okay, so it is having some energy, inlet energy. So when it enters at E1 energy. Okay, now when it enters in the turbine, so it performs the work on the turbine. It rotates the blades of the turbine. So during the work, it will transfer the energy also. Okay, it will release certain heat energy. So at the when that stream comes at the end, so there is a decrease in the energy. Okay, so there is what? There is a exchange of energy, that is energy also, and there is exchange of what? Mass also. So mass of steam here decreases and the energy also decreases. Okay, but what we are doing? This is our system. Turbine is our system. So and there is what? There is exchange of mass also in the form of the steam. And there is exchange of what? Energy also in the form of what? The energy of the steam. Okay, so here both exchange are there. Okay, we have two things you remember: mass and energy. If there is exchange of mass and exchange of energy, then it is an open system. Just remember this one. Okay, you remember these two words: mass and energy. If there is exchange of mass and energy through the system, then that system is called as what? Open system. Now you take the water heater. Okay. Now water heater is also open system, because here, if you see, there is the cold water enters into the heater. So some mass of water enters into the heater. And then when we take the hot water, so we'll get the second, that is the M2, mass of the water. Okay. So that means there is a mass exchange. And we know that inside this heater, we have the electric coils. And because of that, there is a transfer of the heat. So energy. Okay. There is a transfer of energy. So here there is the two types of the exchange of the energy is there in the form of heat and work. So what is that? Exchange of mass and exchange of the energy. So that's why it is called as what? Open system. Okay. So whenever there is an exchange of mass and energy, we call that system as a open system. Now again take the another example, nozzle. Okay, we have seen nozzle. Nozzle is used for what? To increase the velocity. So if we have low velocity water, if you put the nozzle on that pipe, so it will give us the high velocity. Okay, for that we are using the high velocity. So nozzle we are using before the turbine. Okay, before the turbine, so that we will get a high velocity. Why we require high velocity? If the steam comes at very high velocity, so then it will rotate the blades of the turbine at very high speed, and there is a generation of electricity. Okay, so that's why we have to attach this nozzle. Okay, there in the steam turbine. Now, this is also this is a kind of the open system. So this is nozzle is our system. This is our system. Okay, we have considered nozzle for our study. So we call this as a system. Now, why we call this as an open system? Now consider, suppose we have the fluid or gas. You can pass anything. Okay, from this you can pass the gas also, or you can pass the fluid also. Water, oil. Fluid means what? It is water, oil, anything. Okay, that flows through this nozzle. So there is what? Suppose we take the oil. So oil will flow at mass M1 and it will come out at mass M2. Okay. Suppose that oil is the oil is what? Heated. Okay. So that is the heated oil. So there is what? There is exchange of what? Energy. There is exchange of energy. Okay. If we consider here the steam. Okay. So steam is also having mass M1, outlet mass M1, and during this flow it will again exchange the energy. So in this system nozzle, we have both exchange of mass and exchange of the energy. So that's why we call this system as what? Open system. Okay. So nozzle is a open system. Now consider the compressor. We have just discussed about the air compressor. Okay. Or the what we have that discussed about the hydraulic the compressor also. Now if the fluid is there, so reciprocating compressor. So when that fluid enters into the compressor, so this is having some mass M1, and we are removing some mass of the fluid that water. So if we take the air, then it become air compressor. If we take here the water, then it becomes hydraulic compressor. Okay. So if air enters at mass M1 and if it is coming out at mass M2, so there is what? There is an exchange of the mass. At the same time, when we compress the air, its temperature increases and there is exchange of what? The removal of the energy. Okay, the compressor get heated. That means there is generation of the heat and there is a removal of the energy. Okay, so that means here what happens? There is an entry of mass also. There is a exchange of mass. At the same time, there is exchange of the energy also. And whenever there is an exchange of mass and energy, so we call that system as open system. Okay. So these are the four examples of your open system. So which system will call as open system? So a system which allows mass transfer as well as the energy transfer. So that system is called as what? Open system. Okay. So this is the examples of turbine, water heater, then nozzle and compressor. These are the examples of your open system. Now, again, the last example is the of the open system is the cup of the tea on the table. Now, this is the familiar example. If you put the cup of the tea on the table. So what will happen? There is the release of energy. Okay, and here in this case, you will see that there is the removal of the mass in the form of what? The evaporation. Okay, so that means there is the exchange of mass also and exchange of the energy also. Okay, so that's why this is the cup of table. If you put the cup with the hot coffee or tea on the table, so that system is called as what? That system is called as the open system. Okay, here the mass is in the form of what? Evaporation. So mass get removed in the form of the evaporation, and the heat get removed. Okay, so that's why it is called as the open system. Okay. Now closed system. Now what is this mean by the closed system? So first of all, we have to consider the system. So consider any system for our study. Now in closed system, there is no exchange of mass. There is no exchange of the mass. We have two things. One is mass, another is energy. In previous one, we have seen there is the exchange of both mass and energy. That's why we call it as an open system. Now in closed system, there is no exchange of mass. There is only exchange of energy. So if in a system there is only exchange of energy, then that system is called as what? It is called as the closed system. Okay. So here you see there is no mass transfer, but there is only the transfer of energy. So then that in that case, that system is called as what? That system is called as closed system. Okay. So see the difference. If mass and energy, we have mass and energy. If exchange of mass and both mass and energy is there, it is open system. If we have only exchange of energy and not the mass, then it is called as what? It is called as the closed system. Okay. So here it is only exchange of energy. Okay. Now let us see the examples now. In closed system, so cylinder fitted with the movable piston. So if we consider the gas inside the cylinder, and if you heat that gas, okay, so what will happen? So its volume increases because of the increasing temperature of the gas. It will push the piston upward. Okay, so because of that, what will happen? Its volume increases. So volume increases from 1 meter cube to 3 meter cube. But there is no change in the mass of the gas. The mass will remain same. Okay, so what will happen here? There is the initial. This is the initial temperature of the. This is the initial temperature or the initial temperature of the gas. Okay, and now this is the final temperature of the gas. Now this T2 is greater than what? T1. Why? Because we are heating this gas. So there is a exchange of the energy. We are exchanging the energy with the gas, but there is no exchange of mass. Okay, so mass is what? It is mass remain constant. Okay, the mass remain constant here. Okay. So that's why this is the closed system. So cylinder fitted with the movable piston. Okay. Next one is what? Car battery. If you have seen the car, we have seen this one, the car batteries. Okay, so our batteries which are available with us. Okay. So here what will happen? We have here the acid. Okay, we have acid inside this battery. Okay. So this mass remain what? This mass remain constant. Okay, this mass remain constant here. Okay, during the operation. But during the operation, there is a generation of what? There is a release of the energy in the form of the heat. Okay. So car battery is also the examples of our closed system. Okay. This is the examples of our closed system. Okay. So here mass remain constant, but there is an exchange of heat during the operation. Okay. Then we have pressure cooker. Now this is the well-known example, pressure cooker. When we cook something here, so the mass of that food inside this pressure cooker, so we consider that as a constant, while there is the exchange of what? Energy. During the cooking, there is exchange of energy, but the mass inside this one, it will remain constant. Okay, so we consider that as a constant here. So that's why this is also our closed system. When mass is constant, so that is what? That is our closed system. Okay. Now refrigerator also, I have told you here also everything which is there inside this refrigerator, so that mass remain constant. But if you see, there is an exchange of energy because there is a refrigerant inside and there is the removal of the energy. If you put your hand on the back side of this refrigerator, so then you will feel the hot air which is coming outside from this refrigerator. So that means what? That is, there is an exchange of energy, but there is no the change in the mass of the system. Okay, so that's why we call all these systems as a closed system. Okay, so what is the difference between this one? See, in closed system, what we have seen. So in closed system, we have mass and energy. So there is no exchange of mass, but there is exchange of energy. If there is exchange of mass and exchange of energy, so you call that system as a open system. Okay. Now the third case. Now the third case is what? Now there is no exchange of mass and there is no exchange of energy. Okay, so then that type of system is called as what? If that system is not exchanging mass and not exchanging energy, then that system we call that as an isolated system. Okay, so this is the system. So a system which in which neither mass nor energy is permitted to cross the system boundary, then it is called as the isolated system. Okay, so this is the the third type of system, that is the isolated system. So, okay. So now you can easily differentiate here. See this one. Okay. Here, this is M and E. This is M and E, and this we have three types of system now. You can define here like this. Okay. If both are permitted, open system. Okay. If only energy is permitted, then it is closed system. And if both are not permitted, then it is what? Isolated system. What is the example of isolated system? It is thermos. Okay, if you put anything on suppose if you put some mass, the copy in the form of the what, so that is the mass of our the tea or coffee inside this thermos, and there is no exchange of energy. Okay, you will get hot coffee after 5-6 hours. Okay, so that means there is no exchange of the heat. Okay, so here this is thermos. Similar, that is the electric oven. Okay. So electric oven is also example of isolated system. So here this is your mass. So there is no exchange of mass. At the same time, there is no exchange of energy here in the electric oven. The heat is not coming outside from this oven. So electric oven is also considered as the isolated system. Okay. The famous example is thermos. You also remember the electric oven. We are generally using this in the kitchen also. So this is electric oven, or in pizza houses, so they are using these ovens. So electric oven is also considered as one of the type of the isolated system. Okay. So these are the three types of the system. So that you have to remember. Now, okay, now just identify the types of the system now. So what are the different types of the system? So I have told you three types of system. One, that is the open system. Okay. Then I have told you the open system. Then we have discussed about the closed system. And then we have the isolated system. Okay. So here M and E. Okay, here both are there. Here we have only E, and here we don't have anything. M is not there, and E also is not there. Now thermos, you know that we have just seen. The thermos is what? There is no exchange of mass. There is no exchange of energy. Isolated system. What is air compressor? In air compressor, there is the entry of mass. The mass of air, there is the output. There is output of air is also okay. So mass of air is also there, output. Okay. At the same time, there is what? Exchange of energy. If you put your hand on that compressor, your hand you will feel that compressor material hot. Okay. So it get heated. Okay. So that means there is the generation of energy. So mass also, the exchange of mass, exchange of energy means what? It is an open system. So air compressor is an open system. Pressure cooker, in pressure cooker, the mass remains constant, but there is exchange of energy. So a system in which there is the mass remain constant, but there is exchange of energy. So we call that as a closed system. This is a closed system. Now this is what? This is your refrigerator. This is the one kind of your refrigerator. In this refrigerator, okay, so here again the mass of the refrigerator remain constant, but there is what? Exchange of the energy. So mass remain constant, exchange of energy. So this is your closed system. Okay. So this diagram is for your refrigerator. We call this as a vapor compression cycle. Okay. Your refrigerator works on the vapor compression cycle. So we have seen the refrigerator is an example of what? It is a closed system. Okay, because there is a exchange of the only energy and not the mass. Okay. So this type of question they will ask in the MCQ. They will give you the diagram of the thermos and they will ask you which type of system is there. They will give you the diagram of air compressor and they will ask you which type of the system is this one. Okay. So you have to remember the simple basic concept. Which one? You remember M and E. I have told you. Just see what if there is exchange of these two. So on the basis of this mass and energy, you can identify the type of the system, whatever that system is given to you. Okay. But these are the common systems. They will ask this one, this much only. But we can identify the systems around us also. You take any system and you can find out the exchange of heat and mass between them, and you can classify them into three types of system. Okay, so open, closed, and isolated system. Okay, so these are the types of the system now. Then we'll directly shift to the laws of thermodynamics. So we have already studied this one. So what is zeroth law of thermodynamics? You know this one. Okay, you already studied this one. What is the zeroth law of thermodynamics? Suppose if we consider system A and B. Okay, so what is this zeroth law of thermodynamics state? If two systems are in thermal equilibrium with the third system, that means if the temperature of, suppose T is having 30 degrees Celsius temperature, okay, and this B is also having what, 30 degrees Celsius temperature. That means the temperature of A and B is equal. So we say that A and B are in thermal equilibrium. Thermal equilibrium means what? Their temperatures are same. So A and B are in thermal equilibrium because their temperature are same. Then A and C, okay, the A and C. This is the temperature of C is also 30 degrees Celsius. That means these are also in thermal equilibrium. So A and B is in thermal equilibrium. A and C are in thermal equilibrium. Then in that case, B and C is also in thermal equilibrium. See, this is a simple statement. We know this one, okay? And I already told you, these laws of thermodynamics are taken from what? They are taken from the general, that means from the general nature. That means whatever the activities which are happening in the nature. आपल्या आजूबाजूला जे घडत आहे त्याच्यावरूनच त्यांनी काय केलेलं आहे, लॉज ऑफ थर्मोडायनामिक्स चे आपल्याला स्टेटमेंट्स दिलेले आहे. So what is this zeroth law of thermodynamics? So zeroth law of thermodynamics says if two systems, which are the two systems? Suppose this is A and B. If they are in thermal equilibrium with what? The third system, okay, then they are also in thermal equilibrium with each other. So if A and B are A and B and A and C are in thermal equilibrium, then B and C are in thermal equilibrium. Okay, so that is called as what? The zeroth law of thermodynamics. Okay, so this is again the same thing. This is again the same thing. Now this is our first system. Okay, this is our second system. This is our third system. If you measure the temperature of the system, system 2, that means if this temperature is equal to this temperature, that means this one, and if this temperature is equal to the temperature of system 3, then the temperature of the 2 and 3 become same. Okay, so if a system is in thermal equilibrium with if the two systems are in thermal, if the two systems, okay, are in thermal equilibrium with the third system, then they are also in thermal equilibrium with each other. So A and A, suppose A, C and B, C, or we consider A, B and A, C. These are the two systems. They are thermal equilibrium with each other. Then B and C also will be in the thermal equilibrium. Okay. So these are in thermal equilibrium. These are in thermal equilibrium. Then B and C also will become in thermal equilibrium. Now, why this is called as zeroth law of thermodynamics? Okay. So anyone knows about this one? Why this is called as zeroth law of thermodynamics? Any answer? Why this law is called as zeroth law of thermodynamics? Anyone knows about this one? Okay. How many laws of thermodynamics are there?
Total 4 laws. Zeroth law.
Yes, total 4 laws are there. Okay, first is called the first is the zeroth law of thermodynamics. Then we have first law of thermodynamics. We have the second law of thermodynamics. We also have the third law of thermodynamics. Okay, so total we have 4 laws of thermodynamics. Yes, very good. But why we call this as a zeroth law of thermodynamics? Why do we call this as a zeroth law of thermodynamics? See, why this law is given as the zeroth law of thermodynamics? Because initially the first law of thermodynamics, first law, second law, and third law of thermodynamics. So these statements are stated first. Now what happens? First, we got the statements of first law of thermodynamics. Then after that, we got the statements of second law of thermodynamics, and then we got the statement of third law of thermodynamics. And then after this third law of thermodynamics, then another law appears. Okay, this law appears. Okay, they found this law. Okay, now they don't have now they have two options to put. That means they have the two options now. They will call this law, which one? This law. Okay, whatever we have seen now, this one. So they will call this law as a fourth law. Okay, they will put after third, or they will put before the first. So if they put before first, then it becomes what? 0. And if they put after third, then it becomes fourth. Okay. Now, why they have put here then? Why they have put it here and not on the fourth? Because this law, which law? The zeroth law of thermodynamics. This one. Two systems are in thermal equilibrium with the third system. Then they are in also in thermal equilibrium with other. Now, this is the basic law, and this concept is already incorporated in first law of thermodynamics, second law of thermodynamics, and third law of thermodynamics. Because this is a general concept, and this concept was already, that means already used in first law of thermodynamics, in second law of thermodynamics, and third law of thermodynamics also. This is related with the three laws. So they thought, instead of, that means they must put this before the first law and not after the fourth law. Why? If they put after the third law, that means it is an extension of the law, but it is not the extension, it is a basic law. So basic law is always put before the first law. So that's why they put it here. So before the first, that means we have zero. So that's why it is called as what? It is called as the zeroth law of thermodynamics. Okay. So just remember this one. Why this law is called as zeroth law of thermodynamics? Because the basic concept of this zeroth law of thermodynamics is already using first, second, and third law of thermodynamics. And then to put the law, this law, they have put it before first law of thermodynamics. Before first, we have what? Zero. So that's why it is called as what? Zeroth law of thermodynamics. Okay. So this is the zeroth law of thermodynamics. Okay. Now just let us see the. Okay. Now we'll just quickly see these two the basic concept, and I will not take much of your time here. Now reversible process. Now what is reversible process? Now reversible process means if the process is going from suppose 1 to 2, okay, if the process is going, that the process is happening from 1 to 2, and again it is coming back to its original position, then that process is called as what? Reversible process. If you are doing something, that means from, suppose I am doing that one, and I'm going from 1 to 2. That means suppose you are we'll consider you are coming from your hostel to the college, and again by the same route you are again going to the hostel. Okay, so then and by the same route, okay, by the same route. Now you don't have to take another route. Then it is called as what? That is, then it is called as what? Reversible process. Okay, so examples are compression of the spring. Okay, then the balloon. Okay, then motion without friction, electric circuit with zero resistance. These are called as what? A reversible process. We call this as a reversible process. Okay. So compression of spring. So if you compress the spring and if you release the spring, then it comes to its original position. Okay, rubber band. If you stretch the rubber band, if you release the band, then it comes to its original position. So that's why we call that as a reversible process. Now, what is the irreversible process? We'll again take the same position, same example. You are coming to the college from your hostel. Okay, you are coming from the college from the hostel, but now you are not going to the hostel. Now you are going what? In Pencil Chowk, then you are going to Reliance Mall. Okay, and then you are coming to your hostel. Okay, like this. Okay, so what is happening there? Now you are not followed your initial route. Okay, the route by which you have come to the college. So you are not going by that route. Okay, but you have taken another route. Okay, so that's why this process is called as what? This is called as what? The irreversible process. So in this irreversible process, you are not going to college. We are not coming to the hostel, but we are going to what? We are going to Reliance Mall for watching movie here. Okay, so we are not here, but we are now here. We are in Reliance Mall. Okay, so that's why it is called as what? It is called as the irreversible process. Now, what is the irreversible process? Now, the spontaneous chemical reaction. Okay. Then flow through the restricted wall, stretching of the wire. So these are the examples of the irreversible process. Okay, irreversible process means what? That means we cannot come to its the process by means we have taken one process, but we are not coming to its initial position. Okay, that means in initial state. So that is called as what? Irreversible process. So reversible process and the irreversible process. Okay, so these are the two types of the processes are there. Okay. Now the cycle means what? It is again the same thing. In cycle means it is you are going from one position to another position and coming back to its original position. So we call that as a cycle. Okay, it is just similar to the reversible process. Reversible process means what? In reversible process, we are following the same route. That means only one line, 1 to 2. Okay, and then you are again traveling on the same path. Okay, you are going from 1 to 2 and again coming back to the 1 on the same path. So that is called the reversible process. What is cycle? Cycle means what? You are coming to the college from this direction 1 to 2, and then you are going to Pencil Chowk, and then from Pencil Chowk you are coming to the hostel. So that is you have taken another route. So this is route 2 and this is our route 1. But you have reached your initial state. But you have come to you have reached the hostel. Okay, but by another route. Then what you have completed? You have completed the cycle. Okay. So the difference between the cycle and the reversible process is what? In the reversible process, if you reach from 1 to 2, then you have to come back by the same route. You have to come back by the same route to the position 1. Then that is called as what? That is called as the reversible process. And if you are taking the another route and then coming to the original position, then we call that as a cycle. Okay, so this is the difference between the two. Okay, just remember this one, the words only. If they ask in the MCQ question, so you must know what is the difference between the cycle and the reversible process. Okay. Now this is thermodynamic equilibrium. Okay, thermodynamic equilibrium is what we have just seen. Thermodynamic equilibrium. So that we have thermal equilibrium. We have seen thermodynamic equilibrium is what? It is the equilibrium of mechanical equilibrium, thermal equilibrium, and the chemical equilibrium. So in MCQ question, generally they ask this question. So a combination of mechanical equilibrium, that means no forces are acting. Thermal equilibrium, that means there is no exchange of heat, and chemical equilibrium means there is not occurring any chemical reaction. So if in a given system, okay, we have mechanical equilibrium, no forces are acting, thermal equilibrium, no exchange of heat, and no chemical reactions occurring in the system, then we call that system as a thermodynamic equilibrium. Okay, so this is the definition of your thermodynamic equilibrium. So we call that as a system is in thermodynamic equilibrium. When the system is in thermodynamic equilibrium, when it is in thermal equilibrium, it is in mechanical thermal equilibrium, and it is in chemical equilibrium. Mechanical means it is no forces acting on the system. Thermal means no exchange of heat, and chemical means there is no the reactions occurring in the system. Okay, so these are the thermodynamic equilibrium. Okay, so for today, I think we will stop here for the first law and the first law of thermodynamics, and the other things we will discuss in the next lecture. Okay, so let me just revise what we have seen here. So we have started with the definition of the thermodynamics. Okay, and we have discussed three types of the system. Okay, so system, we have open system, closed system, and the isolated system. So that depends on the combination of the mass and energy. If there is exchange of mass and energy, it is open system. Okay, if there is only exchange of the energy, then it is a closed system. And if there are if both the system, if there is no mass and energy, then it is an isolated system. Okay, so these are the examples we have seen. After that, we have seen the zeroth law of thermodynamics. This is very important. If the two systems, okay, suppose this is B and C. Two systems means suppose this is B and C. If these two systems are in thermal equilibrium with the third system, okay, that means if the temperature of B is equal to the temperature of A, and if the temperature of C is equal to the temperature of A, then the temperature of B and C are equal. Okay, what is this? Two systems are in thermal equilibrium with the third system. So that is given here. Okay, and then we have seen this the reversible process and the cycle. Okay, so definition you have to remember. After that, with these basics, now we will study the Joule's experiment, that is the first law of thermodynamics, and the statement of the first law of thermodynamics in our next lecture. Okay, so thank you very much. Just put your roll numbers in the chat box. I will mark your attendance. Okay, so if you have any questions, you can ask.